Alright, hi students. We're going to start vodcast 2.3. We're going to be talking today about mixtures. We mentioned mixtures in the last vodcast where we were talking about ways that we could split up matter into different parts. We had pure substances, which was compounds and elements, and then the other half was mixtures. We could split mixtures up into two types. The first of these is what's called a heterogeneous mixture, which means that it's not the same thing all the way throughout. It doesn't have a uniform composition. And what we got here is a piece of granite, which is essentially a mineral that is composed of at least sort of three different, or a type of rock that's composed of at least three different types of minerals. So these are three different substances, and if you look at it, they're not evenly distributed. Okay, there's more of the black spots in some places, and then there's more of the quartz in some places, then there's some of the little pink spots in different places. So it's not the same throughout. If it is a mixture where everything is the same throughout, that is what we call a homogeneous mixture or a solution. It always has a uniform composition. It's always the same all the way throughout. And of course, my favorite example usually being something like sweet tea. And if it's blended right, at least, everything is the same all the way throughout it. There's nothing different about it at any point. A good sort of analogy that I like to make a lot of times to tell the difference between a homogeneous mixture and a heterogeneous mixture is to use two kinds of soup. If you've got tomato soup and you've got vegetable soup, okay, and just sort of picture those in your mind. Tomato soup is the same all the way throughout. I mean, it's all sort of one evenly blended sort of, reddish orange mass of soup. That is a homogeneous mixture. It's the same all the way throughout. Your first bite is probably pretty much the same as your last bite. On the other hand, vegetable soup is what we call a heterogeneous mixture, because you might get a little scoop where you've got a carrot and a potato, and the next scoop might have like 3 peas and a carrot on it. It's different all the way throughout. It's not evenly blended everything together. Now, typically we think of solutions as being liquids, where we've got something that's dissolved in a liquid. That doesn't always have to be the case. An alloy is a good example of what we call a solid solution, where we've got different metals that are blended together in such a way that they're evenly distributed. And one of the best examples of this, and most important probably, is that of steel. And what steel is an alloy where you've got iron in it. That's the main component. And then you've got little bits of carbon in it called coke. And then depending on the type of steel, you've usually got some parts of other types of metal in there. So like surgical steel tends to have, or stainless steel tends to have chromium in it. There are types of steel that might have titanium in them. Some other types of steel have nickel in them. And they're all solutions because you mix all the metals together at these high temperatures like they have in the smelting pot here, and then they're evenly blended, and so that makes them a solution or a homogeneous mixture. Homogeneous mixture and solution mean the same thing. So, and this is what's popping up in the notes here. Just remember, the key word for homogeneous or for solution is that everything has to be pretty evenly blended together. Now, when we make a solution, there's sort of two terms and two things that we really need to get in our head, and these are the solute and the solvent. The solute is the thing that you are dissolving, and the solvent is the thing that's doing the dissolving. So, like if you were going to make some Kool-Aid at home, you would add sugar and some Kool-Aid mixture. Those two things would both be solutes to the solvent, and the solvent then would be water. So water is then going to dissolve the sugar and dissolve the Kool-Aid in the Kool-Aid packet that you put in there, and you're going to stir it up until it's all evenly blended together, and so it's going to be a solution. Water is usually our solvent. Certainly for everything that most everything that we're going to do in Chem 1, water is typically the solvent. In fact, it's used so much that it's called the universal solvent. And it's used so much that solutions where water is the solvent have a special name. They're called aqueous solutions. And really, to chemists, this sort of makes up a fourth phase for us. We talked about gases, liquids, and solids. In chemistry, aqueous solutions are kind of like the fourth phase, things dissolved in water. Something that's very similar to a solution is a colloid. And a colloid, basically, it's a mixture, just like a solution, where it's pretty evenly blended together. but the particles are bigger than they are in a solution. In a solution, when you put the sugar into the water and stir it up, pretty much everything gets completely dissolved. In a colloid, not everything is going to be dissolved, so you might have some bigger particles there. A good example of this is something like milk or paint, where you've got bigger particles. And down here on the picture on this slide here, it shows you how you can tell the difference between a solution and a colloid, because a lot of times they both look completely clear, like everything's blended together. So the way that we're going to tell them apart is to shine a light through them. The particles are not visible until you shine a light through them, and then when you shine a light, those bigger particles in a colloid, bigger than a solution, are going to show up, and that's what you're seeing here on the video. When you see this sort of little band here, the little foggy patch there, that's what we call the Tyndall effect. And the Tyndall effect says, hey, this thing is a colloid, not a solution. So on this picture here, the thing on the left, the container on the left, is a solution. Doesn't exhibit any of the little fogginess there. The thing on the right is a colloid because it's exhibiting the Tyndall effect. It's showing a little bit of that fogginess as you shine stuff through it. There's one other sort of category here as we go down from solutions where particles are really small to colloids where they're a little bit bigger to suspensions. Suspensions aren't even, we wouldn't even categorize them even slightly as homogeneous mixtures anymore. These are heterogeneous mixtures, and in this case the solute particles are so big that they're basically all going to fall to the bottom. And the example here in the diagrams here in the pictures are basically if we had some sand or some mud and water. If you stirred it up, it might seem for a second or two like it was evenly blended, but as soon as you stop stirring it, everything is going to start to sink down to the bottom. Think about when we did lab the other day, when we did the separation lab, you had sand and sawdust in there, and when you initially put it in and started stirring, the sand was probably floating up like it is in the bottom pictures here, but then as soon as you stop stirring, stuff all starts to sink down to the bottom. So in a suspension, the particles are much bigger. You can actually see the particles. They're visible. In a colloid, you can't see them, at least until you do the Tyndall effect. But in a suspension, you can pretty much see everything. And again, when you just set it there for a second, everything is going to start to slowly or quickly start to fall to the bottom. The slowly or quickly sort of depends on exactly how big the particles are. And this is going to be one of the things that's going to be kind of important for us is how can you tell the difference between a solution, a colloid, and a suspension? A solution, everything's evenly blended. A colloid, everything looks like it's evenly blended, but if you shine a light through it, you get the Tyndall effect. In a suspension, things are going to fall to the bottom. Okay? Even if it looks like it's blended up initially, if you just even let it sit there for a couple of seconds, everything is going to settle down to the bottom. Okay? So that basically makes up what a suspension is, and that's sort of one of the three types of mixtures that we really want to focus on here. Thanks, guys.